In this video, we will introduce the idea of monomial expressions and then look at their behavior for values of x greater than 1. So a monomial expression is an expression of the form a times x to the n, where a is any constant value and n is some constant non-negative integer like 0, 1, 2, 3, or any other larger integer. So some examples of this are, one, we could say x squared is an example of a monomial expression, or we can multiply that by 3, so 3x squared is an example. Negative 2 times x squared. Some other examples, 5 times x to the 5th, or 5 times x to the 1800, or even something like 10 is an example of a monomial expression because 10 can be written as 10 times x to the 0. And x to the 0 is just equal to 1 for any value of x. So let's compare the values of x to the 4th and x cubed for values of x greater than 1. So let's look at the behavior of these two monomial expressions for values of x greater than 1. So as a starting point, let's say x is equal to 5, in which case x to the 4th is equal to 5 times 5 times 5 times 5, and x cubed is equal to 5 times 5 times 5. And since x to the 4th has an extra factor of 5, that x to the 4th term should be larger than x cubed. So in this case, for x equal to 5, we would say x to the 4th is greater than x cubed. We could have picked any value for x greater than 1 and said the same thing. Anytime we have this extra factor that's greater than 1, that x to the 4th will be greater than x cubed. So this inequality, x to the 4th greater than x cubed, is actually true for all values of x greater than 1, not just x equals 5. Now in general, we could say that x to the m is greater than x to the n whenever m is greater than n. And now this is the case where x is greater than 1. So anytime we have x greater than 1, if we make our exponent larger, our actual term's value will get larger as well. This is true because whenever we multiply by a number greater than 1, it produces a larger value. So having a larger exponent results in a larger value.